Very good morning, students. Today we are going to learn chapter 4. Topic name is permutation. So first let us understand what is permutation. So permutation is the arrangement of things and the order in which things are to be placed is very important. So let us take three things first, or else three letters. Let A, B and C. These are the three letters. So if I want to take letter A, so in how many ways I can arrange this in a particular order? Let us suppose these three letters, how many ways we can arrange in the sense. First, if I take letter A, then I can write it as, I can take B and next I can take it as C, or else I can take first C, next I can take it as B. Suppose if I start with B letter, first I will take with A and next I will go with C. So I can take with C here and here A. If I start with C, then I left with two letters, that is A and B. So I can write here A and here B, or else B and A. So totally if I take three letters, then it is getting totally six combinations, six arrangements I can do in a particular order. So the orders are ABC, ACB, BAC, BCA, CAB and CBA. These many ways I can arrange the three letters. Thus, if three letters can be arranged in 3 factorial ways. So in the previous class we have learned about the factorial. So 3 factorial value is nothing but 3 into 2 into 1. So which is nothing but 6 ways. Suppose instead of 3 letters, if we are having 4 letters, let us see that. So instead of 3 letters, if we are having the 4 letters, thus if we have 4 letters, then number of ways of arranging in order will be 4 factorial ways, that is 4 into 3 into 2 into 1. 24 ways we can arrange. These are the one case. Now let us take, suppose if we have 10 letters. So let us think that if we are having the 10 letters that are A, B, C, D, E, F, G, H, I and J. So these are the 10 letters I have, and we need to make a 3-letter string. So I need to make a 3-letter word, 3-letter string. So find the number of ways. So find the number of ways of arranging. So since we have 3-letter string and we are having the 10-letter word, so we can make it in terms of letters. Suppose 3 letters. So 3-letter string is there. 1, 2, 3. So in this 3-letter string, if I want to place these 10 letters, so in the first I can put all the 10 letters, so it will be 10. Next, if I want to put here, in this case I have not said any kind of repetition is allowed. So if repetition is allowed, it will be 10 into 10 into 10. Since in the question there is no repetition allowed, that's the reason. So already one letter will be joined in this, the remaining will be 9 letters. So it will be 9 here and the remaining will be 8 letters. So the answer is 10 into 9 into 8. So it can be arranged in 10 into 9 into 8, that is 720 ways I can arrange. So the question is number of permutations. Number of permutations of 10 different letters in 3 different ways. In 3-letter string. So we are going to arrange 10 different letters in 3 different string. So it can be arranged as ten into 9 into 8. So this is what we have done. Now this can be written as 10 into 9 into 8 into 7. So since I have written this as extra, I will write once again. So if I cancel this, again I will get the same answer. So this can be written as 10 factorial and this can be written as 7 factorial. So I will write it as 10 factorial by 10 minus 3 factorial. So to derive the formula of the permutation, we can write it as for any number of distinct permutations, distinct means different permutations made of or objects made from n different objects is given by n factorial by n minus r factorial. So it is denoted by permutation denoted by NPR. Next, let us talk about the permutation of distinct objects. So permutation of distinct objects. So let S be a finite set. S is equals to x1 comma x2 comma so on up to xn letters are there. So a permutation can be defined as number of bijective functions made on set and by itself. Thus, number of permutations is given by number of bijective functions. So how many number of bijective functions are forming, that many permutations are going to happen in a set. Let us discuss about theorem 4.1. So if n and r are two positive integers, and r is less than or equals to n, then number of permutations of n distinct objects taken r at a time is given as n into n minus 1 into n minus 2 into so on up to n minus r plus 1. Next, theorem 4.2. If n is greater than or equals to 1 and 0 less than or equals to n or less than or equals to n, then number of permutations NPR is given as n factorial by n minus r factorial. So there are two cases in this. So we can mention it as note. So NPR is equals to, so there are two cases. The first one is n factorial by n minus r factorial for r less than or equals to n, and the second case is 0 for r greater than n. It means that if r value is greater than n, then we have to put it as 0. If r value is less than or equals to n, we have to use the formula as n factorial by n minus r factorial. Next, another case is NPR. So NPN and here NP0. So NPN is n factorial, NP0 is 1. So for r is equals to n, for r is equals to 0. So when r value and n value both are equal, we can use directly factorial. If r value is 0, NP0 value is 1. So these are some important results which we have to remember. Next, let us talk about theorem 4.3. So the number of permutations of n distinct objects taken r at a time where repetition is allowed. So very important this one. Where repetition is allowed, then it is n power r, n to the power r. Okay, let us discuss in the exercise this all questions. So let us talk about the properties. So we have totally 3 properties. The first property is that NPR is equals to NP n minus 1. Here NPN is equals to NP n minus 1. So this is one of the important result. If we do the derivation of this, we are going to get NPN also. Next, the second one is NPR is n into n minus 1 PR minus 1. And the third result is NPR is equals to n minus 1 PR plus R into n minus 1 PR minus 1. So these are the very important properties, so which will be useful for solving our questions. So if we take and derive this, we are going to get it as n factorial. This also we are going to get it as NPR. This also if we derive, we are going to get it as NPR. Now let us start discussing exercise 4.2. exercise 4.2. The first question, if n minus 1 p3 divided by np4 east is equals to 1:10. So we need to find out the n value in this. So this can be written as n minus 1 p3 by np4 is equals to 1/10. So it is NPR. We know the formula for NPR, n factorial by n minus r factorial. So that is n minus 1 factorial by n minus r factorial. That is n minus 1 minus 3 factorial by, this is n factorial by n minus r factorial. This is n, this is r. So n minus 4 factorial is equals to 1/10. So this will be n minus 4, this will be n minus 4. N minus 4 factorial, n minus 4 factorial gets cancelled. So the left terms are n minus 1 factorial by n factorial is equals to 1/10. So this can be written as n minus 1 factorial as it is, n into n minus 1 factorial is equals to 1/10. N minus 1 factorial gets cancelled. So if you do cross multiplication, n is equals to 10. Okay. Next, let us do the third question. Okay. So here the question is exercise 14.2 third bit first up subdivision. 8 people are entering into a swimming pool event. So there is one event in swimming pool. They are going to participate. 8 people are there. So there are 3 prizes. One is gold, silver and bronze. So we need to find out in how many ways we can get this gold, silver and bronze. Let us see the solution for this. So totally we have 3 prizes. One is gold, one is silver and one is bronze. So here gold we are going to get in, it may be getting for 8 people. So already 1 people got the gold, so definitely the remaining 7 people it may be choice of getting silver, and the remaining 6 people it may be choice of getting bronze. So it will be the combination of 8 into 7 into 6. So that will be in one way. In the normal way we can do that. Here 8 distinct people taken 3 at a time is given as 8p3, that is 8 factorial by 8 minus 3 factorial. So that is 8 factorial by 5 factorial, which is 8 into 7 into 6 into 5 factorial by 5 factorial gets cancelled. So the answer is 8 into 7 into 6, which is 336 ways. So we are going to get in 336 ways. Since here repetition is not allowed, we are taking one prize already. If we are assuming it as getting gold, so the remaining people will be 7 and the remaining people will be 6, like that. So either this is one way of doing, this is the another way of doing. Okay. So let us discuss third bit, second question, second subdivision. So there are totally 3 men which are having 4 coats and 5 weights and 6 caps. In how many ways they can wear them? Okay. The first scenario is 3 men can have 4 coats. So it will be in the form of 4p3 ways. Next, 3 men can have 5 waistcoats. So it will be 5p3 ways. And 3 men can have 6 caps. So it will be 6p3 ways. Now you may be having a doubt like why we are not keeping 3p4. According to our condition, R value should be less than m. So definitely it will be 4p3 ways. So therefore total number of ways is equals to 4p3 into 5p3 into 6p3. So that is 4 factorial by 4 minus 3 is 1 factorial into 5 factorial by 5 minus 3 is 2 factorial, 6 factorial by 3 factorial. So that is 4 into 3 into 2 factorial next 5 into 4 into 3 factorial into 6 factorial by 2 factorial into 3 factorial. So the answer is 12. Here it is 20 and 6 factorial, 6 into 5 factorial. So if we do total multiplication of that answer, so we are going to get it as 2800. Now the next question, exercise 4.2, fifth question. A test is consisting of 10 MCQs, multiple choice questions. In how many ways test can be answered? First subdivision is each question has 4 choices. So here the repetition is allowed. Why we are saying repetition is allowed means, so in the probability chapter we have learned few things like whenever we are tossing a coin, 2 power n is the formula. Why? Because 2 choices are there where it can form. So the 2 choices, it may be for true or false also, it will be 2 choices. For on the switch, it will be of 2 power n only. But here instead of 2 choices, how many choices we have here? 4 choices. So in that case, so here it will be 4 power, whatever the number of questions are there, that will be the formula. So in answer will be 4 power 10 ways. So already we have discussed theorem 4.3 where repetition is allowed. So in this case, this is a special question in which the 4 choices, so this type of question we have to observe that. And let us see the solution. So in this case, whenever we are doing this type of questions, we have to use the formula as n power r. So that is here 4 different objects taken 10 at a time. So here we are taking 4 at a time where repetition is allowed. So the formula is n power r. So that is 4 power 10. Next, let us take the second question. So the second question is the first 4 questions. The first 4 questions have 3 choices and remaining have 5 choices. So here the first question is having the 3 choices. So since there are choices are 3, so the 3 distinct objects in 4 taken 4 at a time is given as 3 to the power 4. So that whatever the choices is given, we have to keep it as base and the power whatever the number of questions are given. Next, that already we have covered here 4 questions. The remaining will be 6 questions. We are having the 5 choices. So that 5 different objects taken. We are taking here remaining 6 questions, 6 at a time. So if we are taking like that, so the answer is 5 to the power of 6. So here is asking number of ways. So number of ways is the product rule, that is 3 to the power 4 into 5 to the power of 6. So these many ways we can answer this. Okay. Next, exercise 4.2, seventh question. How many strings can be made from the letters of the word article? So article is the word here. So that the vowels occupy the even place. So article, it is of 7-letter word. So let us draw 7 boxes. 1, 2, 3, 4, 5, 7. So totally 7. So in these even places 2, 4, 6, only the vowels are going to occupy. Why? Because according to our condition, vowels should occupy only the even place. We have A, I, E, 3 vowels. Which occupy 3 places. So it is 3p3 or else 3 factorial. So that is 3 into 2, totally 6 ways. Vowels can occupy in 6 ways. So the remaining are 1, 2, 3, 4. So the remaining we are going to have the 4 letters which will occupy the 4 different places. So we have 4 different letters with 4 places. So since we are having the 4 different letters with the 4 places, so the formula will be NPN, that is 4p4 4 factorial. So 4 into 3 into 2 into 1, so that is 24 ways. So next, the total number of ways strings can be made is equals to 6 plus 24, which is 30. Why? Because in the first we had already 3 factorial, the remaining is 4 factorial. That is 3 factorial into 4 factorial ways. We can make the strings according to the given condition.